Hello guys, this is Ravi Rajput. Welcome to my YouTube channel Next Gen Neuron. So today I have brought again the same topic, Agentic AI, for you guys, right? So if you remember last time we discussed about core concepts of Agentic AI, how Agentic AI works, and what is the mechanism behind the scene, right? So on the same line, I have developed a small application for just for demonstration purposes for you guys. So on top of Agentic AI. Right, so this is a shopping assistant which works on agentic AI concept, right? So just consider a shopping assistant chatbot. You are talking to it and getting some help for your shopping or for your purchases, right? So this is the same thing. So what it does, it uses an API call, and that API call is associated to another e-commerce website, which is again owned by this Styrish AI only, right? So this website was one functioning years back, many years back, right? But now it's being used only for demonstration purposes. So what this chatbot assistant does, right? So based on your query, if you are asking for anything based on your query, it makes call to these e-commerce APIs, right? E-com APIs of Salezone, and bring the products from its catalog, right? So I have some sample products in its catalog, like in some food items. If you see some vegetarian food, right, or non-vegetarian food, and some apparel items. So I'll show you how it works basically, right? So then we'll get more into the code level details about the implementation. So for example, I'm a customer. I'm just making a query to chatbot, show me some food items, right? So if you see, so what it has done, it has, using some agentic AI concept and using the LLM behind the scene, right? It made some reasoning, and the first it predicted the useful tool based on the user's query, like what tool it should be used. I'll show you how many tools are available and what tools I pass to LLM, right? So it called the search product tools, and also it is the LLM is predicting based on the user's query. LLM is predicting some useful search terms and separating those with comma, and those search terms are being passed to my existing e-commerce API, which is a REST API for search, right? We being used in Salezone application, and bringing the products from there, right? So if you see, I queried, show me some food items. So here are your food items. Do you need any beverages to go with your meal? So this is an intelligent follow-up question made by LLM that shows your AI is working behind the scene, right? Your agent is thinking like a human, right? Or a seller. If you give any beverages to go with your meal, yeah, for example, only having a juice in my catalog, so yeah, yep, some juice. Okay, so if I make a juice, then it should bring some juice as well. So yeah, so here's a product for juice. Do you need any snacks or fruit? I go with it. So if you want to make some more query, right, it should bring you the relevant products as well, right, based on your query. So that's how the agent is working, right? And I think I have some apparel items as well and electronic items. So let me show you some magic there as well. uh, yeah, show me some laptops. Okay, so it's again going to make a call to this Salezone API, right? And it will bring you the laptops. Not professional. I think I am having the laptop in gaming category right now. So it had brought you these laptops only. So yeah, definitely this wallet should not be in this category, but it's just a sample data, forget about it, right? So again, I brought, so, just for demonstration purposes, right? So I'm now going to ask some smart questions. So okay, I'm feeling hungry a little bit. It may have, here are products for quick snack. Do you need anything to drink? go with it. So currently there are no any snacks in it, right? So it's just a message from LLM, but it found zero results from the API. That's why the results are not here. So remember, guys, this is only for demonstration purposes, but it's working core is working properly how agentic AI should work, and um, yeah, how it should be basically, right? So I'm feeling hungry a little bit, so it identified, yeah, so it should go for some quick snacks and food items behind the scene. Maybe snack should be the query. It might have got the zero search results, but yeah, conceptually it is working fine, right? So that's how it goes. Some vegetarian food, right? Let's see how what it gives. Yeah, so here are products for vegetarian food. Do you need to access dressings complement your meals? Yep. So it's working fine. It's perfect. So this is a small application going forward. So currently it is working only for search products. So it can be extended. So if you say please add the second item to the cart, right, or like please add this SKU to the cart, so it will pass that query to LLM, and LLM will do some reasoning, will get the list of tools, find okay what tools to call if you make a query, add this item to cart. So yeah, it's add cart method, right? So it will call that tool, and which will add this item to the cart as well, right? So currently that's not implemented, but that's how it goes. Let me check what it says. Add this laptop to my cart. Okay, so what it okay, so I think that's again it's not working properly because it's not implemented, but yeah. So yeah, if you make a query about add to cart, it will add the same item to your cart as well by calling the appropriate tool. Okay, so currently this agentic commerce chat is limited for searching the items, various items. Now coming to the code thing, I'll show you how it's happening behind the scene, right? So this is a code. I had written some stuff in order to develop this application, right? So the front end is definitely a React, right? It's on React, and it's calling a Python based backend. So let me show you. Yeah, so this is an application, agentic commerce, backend, front end, and search. It's for SSL, right? So front end is this. If you know React, so you know how the project structure should look like. So in app.js, definitely you would see some hard coding and all. Forget about it. This is just a demo application. It's not completely running in live, right? So uh, yeah, this is making call to your LLM or orchestrator or the agentic application, right? So behind the scene, this is my EC2 IP, and yeah, in this backend you would see this is app.py. It's a working Python program which is uh, which is functioning. So forget about it. This is my key. Yeah, the secret key for OpenAI. I have used the OpenAI and got a key for demonstration purposes, right? So OpenAI LLM is being used behind the scene. So I have used LangChain framework. If you had seen my previous video, I had explained how LangChain works in agentic AI applications, right? The same I have used the GPT-40 mini, passing the OpenAI key, and these are my tools, right? The first is extract keywords, second is search products, right? Add to cart, view cart, and many more. So here I had given a list of tools, what tools are being used in this application: search product, add to cart, view cart. So as I mentioned, add to cart, view cart are not being used currently, but those are currently placed as a placeholder. Maybe in future we can implement. The search products is the one which is currently functioning. Conversation buffer memory is a concept. If you want to manage the memory, like if you're talking to to an agent, right? So agent should understand, like keep in its memory, like whatever you have talked in past, right? So it keeps all the memory in a sequential way, and proceed your latest results based on the past memories, right? So same like as you're talking to it. So for now, this memory looks like it's as a global, and definitely it's not going to work if this application is running in live, right? So you need to manage the memory against a particular session, or you can store in a Redis or some cache against the session ID, and making sure you are passing the memory of that user of that session only, and not going to manage at a global level. That can have some bad consequences, but for demonstration it's all fine, right? So the required packages, and this is the magic, guys, right? So it's all happened by a system prompt. So if you read this prompt, you are an agentic assistant, give a user query, only output JSON with, this is the JSON it's going to return, search products or add to cart or view cart. So LLM will decide based on the user query what should be the action, if it is search product or add to cart or what, right? So this action, whatever is being written by LLM based on the user query, I'm executing that particular method to do the certain action, right? So for my all of my user queries here, right? So whatever I had searched, so it should have, based on these queries, it should have written the action as search products only, right? So that's why it called search products, right? So and made the search from that e-commerce application. So yeah, going down below. So yeah, so this is a JSON structure. I'm expecting the response in this format, right? Search product, add to cart, view cart, and the message, some message from LLM to show to the user. So message to show the user, starting with, here are your products or similar text, along with some follow-up questions. For example, if user searches for snacks, follow-up question should ask, do you need sauces or salsa? So if you see that human kind of like human type conversation which LLM is doing, making some uh, follow-up questions, that is happening due to this prompt which I had passed to the LLM, right? So it took the prompt, it know what tool needs to call and what message needs to be written which I can show to user. So it looks like that you are talking to a chatbot agent, right? So this is the magic, real magic of prompt engineering, right? So you definitely this prompt can be more refined and refactored in the real case scenarios, right? Because prompt is the thing which yeah, which makes it possible, or which decides how your application is going to work, right? So this prompt I had passed in this prompt template along with the user query, and everything is being passed in LLM chain, and behind the scene that chain is passing the template and calling the LLM and doing its agentic AI stuff, right? These are just core things, so it should allow some cross domain only for demonstration purposes. And this is the main endpoint which is being called chat endpoint. So now try to understand how it's happening, right? So uh, I'm getting the user's message, right? User's query, and passing that user's query to chain somewhere, right? Where I had passed. I'm calling chain somewhere. See, yeah, chain dot run, right? So this chain dot run, chain is a object from this LLM chain, right? Where LLM and prompt is has been set. So this chain dot run, when that chain runs, it passes your user's query to LLM along with the prompt you had said above, right? And the user's query, and then the response comes from LLM, right? So what the response comes, like response contains the action, what tool it needs to call, search product or add to cart or view cart, and the follow-up message. So again, like based on the queries I made in that application, the chatbot, right? So it might have written the action as search products. So if action equals to search product, then I'm explicitly calling that search product. So that's okay. Your LLM is doing some reasoning, some AI stuff, and returning that the name of the tool, and you're calling it separately to have the higher control on your logic, right? So don't let the LLM to call, or agent internally to be called. For good control, just call it by yourself, right? So search products is being called, and the result is returning here, right? Similarly, if based on the user's query, if LLM predicts, yeah, the action should be add to cart, then I would have called this method add to cart, and you can write the logic to call the add to cart API and all. So this is how it goes. I think that that might have made a clear understanding how Agentic AI application runs. You can develop it in a different way, right? So you can either completely rely on LLM, how it's selecting the tool, or maybe it's calling it or whatever, and returning its own response in human text format. Or what I had done, because I already had my REST API for search, product search written, and it was expecting some search keywords, so I had pass the prompt to predict some useful search keywords based on the user's query, and LLM was predicting the search keywords. Let me show you where it is doing it. Yeah, it is extract keywords here also. llm.predict extract 2 3 search keywords from for this user's query, and then I'm using those search keywords as well as the tool name to decide which function to call. So search products, and calling the Salezone API by search term and passing these keywords into it, right? And that's how I'm using my existing implemented REST APIs as well as the Agentic AI and the LLM to and yeah, and prompting it to call my, I'm using LLM to predict some of the keywords as well as the tool name, and calling my existing search APIs to bring the results for the user. So if any application, any e-commerce company, if they, or anyone who wants to go with shopping assistant based on Agentic AI, and they want to leverage their own existing developed REST APIs, they can go with this approach. But definitely there can be more improvement areas here, because I am currently seeing, for example, I'm calling LLM multiple times here, right? So one is for predicting the tool name, and the second to predict the keywords, right? So this is something which is not good, and also my prompt length is a little longer. So consider if there are so many thousands of requests, so a lot of tokens are going to your LLM, making you more uh, making you more cost, or you have to pay more for that, right? So and calling multiple times the same LLM for each request is definitely going to be expensive for you. So you have to optimize your application in those areas. What could be the immediate action? Like, it's for similar kind of queries, you can store it somewhere in Redis cache, or you can have your small LLM, or whatever. You can keep it in some vector database, right? Where you can make a semantic query, like the similar query, and the tools based on the user's query. You can first check your database or your storage if there is a similar query available. If it is, bring the tools against that query which is in your cache, instead of calling to LLM or bothering LLM for each request. You can do that kind of stuff, right? And definitely using those practices, you can make LLM calls significantly lesser, only when you need it. Uh, when you need it, definite, and not every time, right? And when you need it more, I mean to say. So and also you can optimize, because calling the LLMs are little expensive, and from performance point of view, you can, and just get rid of that thing as well, making your application running smoothly and optimizing its performance and cost optimized as well, right? Because no, you are not calling LLM every time. you are you are resolving the user's query. You are resolving a similar user query as well as the corresponding tool and search terms from vector DB itself before going to LLM. Go when if it is really needed. Go to LLM when if it is really needed, I mean to say. Right. So these things you can opt for your application. You can develop a real-time, a fully production-grade Agentic AI chatbot for shopping. So similarly, you can develop the same Agentic AI chatbot, right? So or agent for anything, not only for e-commerce. E-commerce is my field, right? That's why I had developed it. But like for banking applications, for any other application, right? So in a similar way, just make sure you are passing the right prompt, you are having a right tool, and smartly implemented those tools. If you have your existing website, You have the APIs available, well and good. You can use those. That's an easy approach, guys. Otherwise, it could be a little harder because LLM is predicting some text and you have to parse it to the JSON and a lot of challenges. I faced that when I was developing this demo application. Right, but this is how it goes. I had deployed this application on AWS EC2, and the Docker images are also available. So I had put the Docker image for front and back end separately in Docker Hub, which is being downloaded by EC2 launch template, right? And being deployed there. It's a very simplest way of deployment, but going forward for real-time application, you can do it either by Fargate or serverless Fargate or EKS or whatever you want, right? So that is it. Hope that might have made sense for you and might have made it more clear, because I had followed the same thing what I showcased in my previous video or on the image, like how Agentic AI works, right? So it basically based on the user's query, it passes those users query to LLM and the list of tools. LLM predicts which tool is useful for this query, give it back to you, and you call an agent call that tool for you to do the to execute that operation. Here the same thing is happening, right? So use query is being passed to LLM is predicting the tool name, which is definitely the search product here, and based on the prediction of LLM, I am calling this search product and calling my appropriate API, so and showing the results back to the user. So yeah, that is it. Hope that you might have enjoyed this new revolution in the market nowadays, right? Thank you everyone. Thanks guys. Connect with me for more videos and more knowledge on AIs. Definitely I would be loving to help you guys. Thank you.